Okay, for this one, we are going to look at section 2.2. We're going to look at example 5. And this example wants us to find what's going on with the limit as x approaches 0 of sine of pi over x. So to start out, let's take a look at what's going on as x approaches from the left. What is sine of pi over x giving us back? So we're going to look at this kind of numerically first. Then as x approaches 0 from the right, what is sine of pi over x? What is sine of pi over x giving us back as x approaches 0 from the right? So as we approach 0 from the left, let's see, that would be like negative 0.0001, maybe a negative 0.0005, negative point, let's put 0.00007. So we approach from the right, maybe 0.001, 0.0005, 0.00007. And let's just see, make sure your calculator's in radian mode for this when you go to check out, and your calculator's not in degree mode. So in for y1, I'm going to put sine of pi over x. In for y1 in my calculator, now I'm going to my table, and I put in negative 0.001, and I get back 0. Okay. I put in negative 0.0005 and I get back 0. Let's put this in wrong. Seems okay. So I put in negative 0.00007 and I get back 0.78183. That seems weird. Okay, let's look at doing this the other way. Put in 0.001, I get back 0. I put in 0.0005, I get back 0. Put in 0.00007, I get back negative 0.7818. So let's look at negative 2, 3, 4, 5, 6, and a 3. And maybe, since these are giving me back the same numbers, let me try we'll look at more zeros. So 1, 2, 3, 4, 5, 6. Instead of a 3, let's use an 8. These are approaching some, right now this is weird, because this is going from 0, 0 up to positive 0.7. And then this one's going 0, 0, and then it's going down to negative 0.7. So it's not approaching anything, which is kind of weird. So let's look at point 1, 2, 3, 4, 5, 6, and then a 3. I'm sorry, let me look at negative. Okay, so negative 1, 2, 3, 4, 5, 6 zeros, then a 3. That gives me positive 0.86603. All right, let's look at point 1, 2, 3, 4, 5, 6, then an 8. That gives me, point 1, 2, 3, 4, 5, 6, 7 zeros, then a 5. Okay, so numerically, this does not look like it's settling down on anything. It doesn't look like it's approaching anything. Let's graphically see what's going on and see what's happening. So let me pull up, Desmos. And let's see, we want sine of pi divided by x. Oh, whoops, it's not registering that as pi. What is the pi function here? Is it that? All right, hang on. Sine of pi over x. Okay, so let's see what's happening here. Okay, so this is why we're not getting a limit. As x gets closer and closer to 0, normally the function settles down on a single point, but you can see as we keep scrolling in, as x gets closer and closer to 0, the y values are still bouncing back and forth between 1 and -1. So this function has no limit. This is one way you can fail to have a limit at a value, is if the function is bouncing back and forth between numbers too rapidly. So sine of x over x, because of this issue here, this has no limit. This has no limit at x equals 0. If we looked at like a different x value on the graph, like if we said graphically, what about out here at x equals -1 on the same graph? Well, as you approach -1 from the left, you approach 0. As you approach -1 from the right, you approach 0. So your limit as x approaches -1 in this situation here would be 0. But when you look at 0 itself, that's within this region where everything's going crazy and just bouncing back and forth, so there is no limit in that situation. So that's kind of a weird one. I'll stop there on that example.